that with you. So from there you can see all the things. Okay. So today we are going to see one interesting part of statistics. It is known as combinatorics. So as the name indicates, it is related to some combinations. Okay, it is related to some combinations, and it is nothing but we used to read permutations and combination. It is related to that only. But the name it is given like combinatorics. So what is combinatorics? If you see combinatorics, it deals with the combination of objects from a specific finite set. Okay, finite set. This you should keep in mind. It is a finite set, means you know what all things are available to you. It cannot be infinite, otherwise it will be a task of God, not for us. For human beings, it should be finite. Okay, from a finite set, when we are trying to make combination of objects for a specific task, it is known as combinatorics. Okay, and sometimes we will have some restrictions while doing the combinations. Okay, sometimes we will have some restrictions while doing the combinations. So combinatorics overall, if I read it is like it deals with the combination of objects from a specific finite set, and it also consists of certain restrictions that can be applied to form combinations. We can form combinations. Oh, right. But sometimes there may be some restrictions. So what type of restrictions we may encounter? What type of restrictions we may encounter? It may be first repetition, like I don't want to repeat anything. And sometimes it will be order, like I want combination, but in a certain order. And any other case specific restriction which we don't know, but at the time of solving the case or at the time of solving the problem, it will come at that time only. Okay, so I hope definition of combinatorics and what combinatorics is clear to you. So there are three parts in combinatorics. First is permutations, as you can see here. Second one is variations, and third one is combinations. Okay, permutations, variations, and combinations. And all this we do for our number of favorable outcomes or number of all elements in a sample space. Okay, we know these favorable outcomes. Actually, I will discuss with you in probability class. That time you will be more aware. Till then, we just keep this word in your mind. Favorable outcome. So with these combinations, we try to work out the number of favorable outcomes, or we try to see or try to arrange all the elements in a given sample space. Sample space means whatever finite set of things which are given to us. Okay, so in combinatorics, we read permutations, variations, and combinations. Just 1 minute. Yes, sir. Good evening, sir. Sorry. So now we will start with first. We will start with permutation. So what does a permutation mean? I'll just start with an example and then we will come to it. So what does a permutation mean? Permutation is the number of different possible ways we can arrange a set of elements. Okay, there are a set of elements, and we have to see that how many ways, in how many different possible ways we can arrange this set of elements. Okay, so suppose there are three candidates for a particular competition. Okay, Lewis makes Kimi. No, no, there are three candidates for particular combination. One will be on first position, second and third position, right? So what are the possible arrangements or what are the possible occupancy of rank they can take is we will see one by one. So three candidates and three positions. But someone may take first, someone may take second or third like that. So we'll see first the arrangement one. So in arrangement one, what can happen? Lewis may come first, Max may come second, and Kimi may come third. This is the first arrangement. So I kept Lewis constant on first. Again, Lewis is first, but the position of Max and Kimi is replaced. Now Max is second, Kimi is third. And arrangement 3, Max is first, Kimi is second, Lewis is third. Right. Arrangement 4, Max is still first, second Lewis, third Kimi. And fifth one, now Kimi is first and Max and Lewis will be second and third subsequently in two arrangements. Right. So there will be 6 arrangements like this. Okay, arrangement 1, arrangement 2, arrangement 3. I think by mistake this has come again. Lewis makes Kimi, but you keep in mind that their position is replaced. Okay, Lewis is constant, but Kimi is second, Max is third. Then arrangement third makes Kimi Lewis. Arrangement 4 makes Lewis Kimi fifth and sixth. So if you see for that particular part, we can only have 6 different ways. So there are 6 different ways drivers can split the medal of first, second, and third. So this collectively is called permutation. Okay, there were 3 people. You can see here 3 drivers or 3 race holders, whatever you can call it, and 3 positions. So we did manually all other arrangements. What we could have done possibly for this. So we have arrived to the conclusion that these are 6 people, right? So this kind of variation or this kind of combination when we are doing it is called permutation. So now you see here order was not fixed. Okay, I didn't tell you that no, first you try Lewis only or first you try Kimi or Max only. You have started by your own and that was the freedom given to us. So suppose there are n number of candidates for a particular rank, n number of candidates, and you have chosen one. So naturally for second position you will have n minus 1 candidates, right? There were 3 drivers. Out of that, you have chosen one for the first post. So of course, now there will be 2. That is 3 minus 1. That is n minus 1. And if you go subsequently, it will be n minus 2. Right? First, you have chosen one. Then there will be n minus 1. Then there will be n minus 2. And there are n many elements in that. And here order was not fixed. This you keep in mind in permutation. Order was not fixed. It is your choice or it is the statistician's choice to keep anyone on the first, then second, third he can change. Then he can keep second one on the first and the other second, third he can change. Now you yourself think intuition point of view, if you are developing something in mathematics, you just see from an intuitively point of view. If I'm choosing first person at first post, then there will be n minus 1 and the second, n minus 2 at the third, and at last, of course, you will have only 1% for that position, right? If you have 10 drivers or 10 competitors for 10 positions, at last for the last position, you will have 1% only. Na? That 1% we don't know, but numerically that will be 1 only. Okay, so this will be always 1 at the end. So what we can conclude for this is the further down the ranking we go, the more options we exhaust, right? At first place, lot of options were there, but you have chosen one. Second post, you have chosen anyone. Third post, you have chosen someone else. So at last, as you are going at the last, you are exhausting your options. You don't have much options as you are going down. Okay, the further down the ranking we go, the more options we exhaust. And the more options we exhaust, the fewer options we have left, right? So, this is where the genesis, this is where the origin of factorial comes. Okay, this is where the origin of factorial comes. I'm sure many of you would have read about factorials by now, that factorial 3 is 3 into 2 into 1, factorial 4 is 4 into 3 into 2 into 1. But this is how factorial is derived. That is what I was trying to explain you. Then how it comes into the picture. Let's say I have n number of people. Okay, n number of people. So n, then second position n minus 1, third position n minus 2. At last it will be 1. So if I want to present it with a particular mathematical notation, it will be factorial n. Some writes exclamation symbols, or some write like this also. A half rectangle factorial n, or someone writes like this also. Both are okay. N factorial or factorial n, whatever you can say. So now, as you know, how many drivers we had for the post 3. So n factorial will be what? The product of the natural numbers from 1 to n. So factorial n, 1, 2, 3 up to n. Here, in our case, we had 3 drivers. So 3 drivers mean 1, 2, 3. You can write reverse also. 3 into 2 and so on. It will be 6 only. So I hope the concept of permutation is clear to you, right? I hope the first combination, there are 3 combinations: permutations, variations, and combinations. So in that, permutation is crystal clear to you. Now there are some important points you have to keep in mind. Important properties of permutation. First is that negative numbers cannot have a factorial. Okay, negative numbers cannot have a factorial. And if at all you are reaching at 0, the factorial of 0 will be 1. Okay, factorial of 0 will be 1. Why it will be 1? Because 0 itself is an option. 0 itself is a one option. So one option means that's why 1. Factorial of 0 will be 1. Okay, so these two things you have to keep in mind. Okay. Arti Krishna, are you there? Arti Krishnan,
Yes, sir.
are you
Yes,
there?
sir. Yes, sir.
Okay, so can you just brief me how we arrived at notation of factorials?
So just the definition of factorial.
No, just now we have derived why factorial came into the picture. Whenever we are doing something, factorial of some number, and whenever we are doing factorial of some number, why we are doing it and how it came into the picture, that you briefly explain. Aarti, I'm not able to hear you.
Sorry, sir. I don't know that, sir.
Okay, no issue, no issue. But you see in the recording properly. Okay.
Yes, sir. Yes, sir.
Chandana R, are you there? Chandana R.
Sir, sir, my
Yes.
mic is not working.
Okay. Okay. Saranya Devi, yes. You able to hear me?
Yes, sir.
Okay, so what are the 2 important characteristics of factorials?
So one is the negative number cannot have factorial,
Hmm.
and another one is if we taking a 0 factorial, it will be 1
Why it will be 1?
because 0 is one of the sample we are taking.
Okay, good. Shiva Krishna, you able to hear me?
Yes, sir.
Okay, so just now we have derived the notation for factorial. Can you just brief me what we have done, how we have arrived at that symbol factorial?
Uh, if we have n number of choices, our first choice will be n, and the second will be n minus one, and finally, the last option will be one only.
Okay,
And
what does factorial means? Suppose if I'm writing factorial 4, how I will solve it?
that is 1 into 2 into 3 into 4.
So why we are doing multiplication?
Uh,
Yeah, because I told you there will be first n, then for second position we'll have n minus 1, then n minus 2.
yeah,
And the same
yeah,
thing I can keep at the previous position also. So whatever the previous position is, multiply by the next position, that many option will be there always. So that's why in
yeah.
continuation all are in multiplication.
Oh,
Okay. Yeah.
mm.
Okay, good. So next time I'll ask Vismita, Vishak, Tushara, Sumit, Shruti S. Nair, Sridevi, Sophie Mariam, and Rumaisa and Ria Martin. So be cautious for the next part. Okay, we'll proceed. So by now, what we were seeing is permutations, and now we will see variations. Okay, now one thing you have to keep here in mind. If I'm saying that okay, three drivers are there, and one by one I have seen one driver at first post, second driver at second post. Those are variations only. If you see from a particular point of view and from an English point of view also, I am simply doing variations. But when it comes to statistics, both are not similar. Okay, both are not similar. Means we can say it is similar, but not too similar. Okay, that we will see now. By now we were seeing permutations. Now we will see variations. Now what does variation means? Variations are the total number of ways we can pick and arrange. Here is the catch. Okay, the total number of ways we can pick and arrange some elements of a given set. Okay, in variations, what we can do is that we can pick and arrange some elements of a given set. And in variation also, there will be two types of variations available to us. With repetition, without repetition. Okay, so there will be two things. Variations with repetitions, variations without repetition. Okay, so now we will see ahead. Suppose okay, so first we will start with variations with re repetition. Okay, so here we will see the problem of a combination log. Okay, problem of a combination log. Suppose you have a bag and that passcode जो है उसका जो password है उसका passcode, it consists of two letter code. Okay, it has it is possibility for two codes only, and you have three options A, B, or C. Okay, you have only three options for two for filling two positions A, B, and C, and it is a two-letter code. Okay, so now first we will start with the first one. For the first one also we will have three option ABC. For second option also we will have three option ABC. So suppose you are starting with A. Suppose you are starting with A. So when I am starting with A, again here also I have three option na, unlike the permutation. There, if Louis already came first, he cannot come second also, no? So either it will be Kimi or Max. But here it is not like that. In passcode, if I'm using A here, I can again use A here also. Okay, so we'll have three different options if we decide to start with A. And suppose we have chosen A. Okay, suppose we have chosen A. So again, if I'm choosing A here, I can choose ABC. If I'm choosing B here, I can choose ABC. C here, ABC. So means A, then A, B, A, C. Similar with BA, BB, BC, CA, CB, CC. So simply in variation, when I'm allowing repetition, I'll be simply doing the multiplication of the available options. So 3 options here, 3 options here, 3 into 3, 9. Right? So the total number of variations I can make here is 9. Now you have to keep this in mind. That is the reason we are not calling permutation as variation, because they may look similar, but there is a huge difference between them. Right? Permutation you know already now. So 3 into 3, 9. So how we will write it in mathematical formula? Simply we will put the notation and formula here. V bar np equal to n raised to the power p, where n is the total number of elements we have available, right? And p is the number of position we need to fill. So in our case, the total number of elements available were 3, A, B, and C, right? And number of position we need to fill was 2. So if you do square of 3 square, it will be 3 into 3, which equals 9. All right. So V bar np equal to n raised to the power p. So this is variations with repetition. Okay. Variations with repetition. Now we will see, after this we will see variations without repetition. It is nothing but the same formula I have just pasted again. So the number of variations with repetition when picking p many elements out of n many elements is equal to the power p of the number of elements available, 3 plus square. Okay. Now you know we have ABC V bar 3, 2 equal to 3 square 9. Here n was 3 ABC and p was 2, the passcode. So 9 different variations we can make. Suppose if you have ABC, suppose if you have ABC all 26, what if we could use any other 26 letters? Then it will be 26 square. So 676 different variations you can make in the password of this passcode. Okay, like that we will see other examples, means I'll be giving you for assignment, of course. Now we will see variations without repetition. Here I could repeat it. If A was there at first place, I could repeat again in the second passcode, but here I'll not be repeating it. So we will say variations without repetition. Now suppose there are 5 candidates for a particular team. Okay, but the coach wants 4 only. 5 members are there, but the coach wants 4 only. 5 members are Tom, Eric, David, Kevin, and Josh. Okay. Now, how we will proceed in this case? One by one we will see. Okay, one by one we will see. 4 members he can take, and 5 options are available. Now, suppose these are the post. Okay, so 5 options are there. First one, suppose if he is putting David, so for the remaining 3, he will have Tom, Eric, Kelvin, or Josh. Okay. Again, if he has put Josh, he will have Tom, Eric, Kelvin, and so on. So for the last option, he will have Tom or Eric both. Okay, unlike the permutation here, he will have 2 options, right? So in this case, you yourself imagine each line is example of a single unit of permutation. Single unit of permutation. Here you see at first post he has 5 options. Okay, at first post he has 5 options. At second post he has 4. So so it will be like 5 options for the first, 4 for the second, 3 for the fourth, and 2 for the last one. So it will be 120 different options of how to arrange a particular team for the competition. Okay. Now in this case the formula will be different because the place were 4, but people were 5. In this case the formula will be VPN factorial n upon factorial n minus p. Here number of variations without repetition. Without repetition. You keep in mind here I cannot repeat. I hope you are understanding the things. If already I have put David here, I cannot put David again. But in the passcode system, if I put A in the first place, I was putting A again because variations was allowed in that. Here it is not allowed. Okay, if I have already put David, I cannot repeat him again. Okay. So the number of variations without repetition while when arranging p elements out of total of n, this will be the formula. Now here we will see our example. How many number of people are there with us? 5. So here I'll put factorial 5. Here again I'll put n and p will be 4 because we have 4 slots. So factorial 5 upon factorial 1 equal to 120. Right? The number of variations without repetition when arranging p elements out of a total of n equal to 120. I hope up to this point it is clear to you. So in variations, we have seen variations with repetition and variations without repetition. Okay. Shruti S. Nair, are you there? You able to hear me? Shruti. Okay. Vismita, you able to hear me?
Yes, sir.
So Vismita, very briefly explain what we have done in variations. Just briefly explain what I have explained to you about variations. Start.
Okay. Actually, variation is a total number of ways we can pick and arrange some elements of a set. There are two types. One is with repetition and the other one is without repetition.
Hmm.
In the case of repetition, if we have three people like A, B, and C, um, we can choose a combination of them like A, B, A, C, and in other case B, A, B, 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 C, like that. And in the case of without repetition, it's a single unit of permutation. So we cannot repeat the elements.
Okay, so suppose if 4 positions are there and 5% are there, if I've already taken 1% at first position, I cannot give him
We
second
cannot,
again. So from
we
the
cannot
remaining
choose
only I
him
have to take.
again. So in the first position, 5 options will be there, and in the second position, we will have only 4 options.
Correct. Okay, we'll go ahead. But those who are not answering me, it's not good. If you are attending the class, you have to interact with me. Karthika Nath PR, are you there? You able to hear me?
Hello, sir.
You able to hear me?
Yes, sir.
Can you just brief about what I have explained about permutations?
Yes, sir.
Hmm.
Permutations are the number of different possible ways we can arrange a set of elements. And in the case of permutation, the order was not fixed. That is, we can arrange it in any order. For example, if you arrange in the first position n, then the second position it should be n minus 1 chances, because and in the third position it will be n minus 2, and at last only one only at the end. So further, whenever the rank goes down, options will be exhausted and we only have less option remained.
Yeah, good. Okay. We'll go ahead. So I hope up to variations it is crystal clear to you. Now we will see combinations. Okay, so first we have seen permutations. Then we have seen variations. In variations also we have seen two things. Variations with repetition and variations without repetition. Now we will see combinations. Okay, now we will see combinations. So what does a combination means? The number of different ways we can pick certain elements of a set. Okay, the number of different ways we can pick certain elements of a set. And keep this in mind that it is different from permutation and variations both, that you will come to know after I finish the class and once you will be reading more about it. Okay, so combination is what? The number of different ways we can pick certain elements of a set. Now suppose a particular boss wants to send 3 of his employees to a particular conference and he has 10 employees. Okay, he has 10 employees. Okay, so he has to select 3 people to represent his company. Now, how we will apply the mathematics of combination here? Suppose first thing what you need to understand is that in permutation and combinations, in permutations and combinations, when you are reading about variations and permutations, so variations don't take into account double counting elements. Okay, you yourself would have observed that many times when you are doing permutations and variations, double counting is also there. But when you are actually combining something, you will not be allowed to even count double any particular thing. Let's say here, out of these 3 people, there are 3 members, Alex, Sarah, and Dave. You can see here, Alex, Sarah, and Dave. So if whether I write Alex, Sarah, and Dave, or I write Alex, Dave, and Sarah, all 3 people are same only, na? All 3 people are same. So when they are representing, I cannot say that Alex, Sarah, and Dave combination is different from Alex, Dave, and Sarah. Right, that is what a combination means. But this we were not able to bifurcate when we were doing permutations and variations. When we were doing permutations and variations, when 3 positions were there, Louis, Kimi, and Max, every time those 3 people only were there, Louis, Kimi, and Max, and all 3 we were arranging between them. But in this case, when you want to represent something or when you have a particular task, that Alex, Sarah, and Dave will be same as Alex, Dave, and Sarah. So you cannot say that these 2 are different combinations. Okay. Okay. So the point is variations don't take into account double counting elements. That's why we need combinations. Okay, that's why we need combinations. So what we'll be doing is that we'll be counting every group of 3 people. Now we'll see separately. Suppose first I am choosing Alex, Sarah, and Dave. Okay, so the order in which we are picking them is not relevant. Dave can come first, Alex can come second, or Sarah can come first or second, third anyway. These 3 only have to represent our company. Okay. So suppose if we do 6 permutations here, that will be different variation, but it will not be different combination. Combination will be same, right? If I do permutation of these 3, factorial 3 will be 6. Right, factorial 3 will be 6. So it may be a different variation, but it will not be a different combination. Combination is same only. The same 3 people are there. Okay, I hope you are getting slowly one by one what I'm saying. So the formula in this case will be, so what's the number of combinations for choosing p many elements out of sample space of n element? The formula will be C p raised to the power n is equals to factorial n divided by factorial p divided by factorial n minus p. Okay, now we will put it in the formula. For our example, n is 10 employees, right? I have to take 3 out of them, p equal to 3. So first is factorial n. Factorial n is what? Factorial 10. So factorial 10 will be 10 into 9 into 8 into up to 1. It will come 720. And then factorial p into factorial n minus p. Okay, factorial p is factorial 3 and 10 minus 3 is factorial 7. So if you solve it, it will come 120. Okay, it will come 120. So means I will have 120 combinations in which I will not be repeating the same person again. Okay, I hope it is crystal clear to you. Again, you understand by now we were not seeing this aspect. If some 3 things are there, their variation also we were counting in our calculation. But here, when you are combining them, their variation is a single combination only. Okay, their variation is a single combination only. That's why we need different formulas when we are applying combination. Okay, so suppose if we want to pick 4 people now, okay, it will be factorial 10 will be same. Factorial 10 will be same. Here it will be different. N is 4 and 10 minus 4 is 6. Factorial 10, factorial 4 into factorial 6. So it will be 210 combinations. Okay, 210 combination. So earlier here in this case, our P was 3. We could select 3 employees and our answer was 120. Here P is 4. We have to select 4 and our answer is 210. 1 second. Yeah. So with this combinations is over. So Adira Visi, you able to hear me?
Yes, sir.
Okay. So what is the difference between combination and other two types of combinatorics, that is permutation and variation?
Okay, in permutations and variations, there is like if you are choosing for 2 positions, there is a chance that we could repeat the same one for the second position, even if you are taking it for the first position. So, but in combinations, it will not be the same. So we have to choose different. So the options will should be limited.
Good. Good.
Yeah. So likewise, if we have to choose 4 from a bunch of 10, we should not the first 4 should not be come in the next 4. So that's the main difference.
Okay, good. So any one of you, any doubt in first class and today's class? Don't leave. Feel free to ask me. If you wish me to explain something else, again, I will explain. Andrew, Anjana EI, hence any Gigi, Aarti Krishnan, Aswati, Atira, Ben John. Any doubt? Anything you would like to convey regarding first and second class?
No, sir.
Okay. Ben John, Delna, Devika Yadav, Dia Malik, Gopika Ji, anything?
No, sir.
Okay. Hiba S, Iza, Kavya S Das. Anything clear by now?
Yes, sir.
Okay. Lakshmi Shaji, Nandulal AM, Nayan Dev, Nivedita Nair.
Clear, sir.
Okay, that means you. Okay, that means you are well aware of all the things. Okay, I'll ask later on then. Raj Singh, Reshma CR.
No, sir.
Hello.
Yes. Go ahead.
Saurav.
Yes, sir. Sir.
See,
Acha. Good evening, sir.
Saurav, actually, this variation without repetition is actually permutation, no, as per the concept.
Yes, sir. But in that particular case, permutation can be standalone, but in variation, we will have lot of rakes in that.
That's what I say. If there is a repetition, yes, of course, correct. But variation, yes, when repetition is avoided, it becomes permutation.
Yes. Very well.
So then what is the logical difference then? Nothing, no?
No, sir. In variation, suppose there are 2 passcode. Okay, and 3 options ABC. So if I'm putting A at first place, I can again put A in the second place. But in permutation, if you have already selected someone at first place, you cannot take him on the second place.
That's what I'm saying. See, in permutation, A will not happen. B or C will not happen. But in variation, all this can happen. That's what I'm telling you. So variation without repetition is definitely permutation, right?
Yes, yes. So if you see from one angle, if two passcodes are there, if you see only one passcode, that inside that we are doing permutation. But when it collectively comes together, it is called variation.
And since in scientific terms, we rarely use the word variation. No, we mostly use permutation and combination.
Sir, it depends actually, because many times if you are using some experiments like that in which some of these things are not required, we use also. And unfortunately, here in CSR labs, we usually don't start with statistics. We'll learn everything. Then data will be there. Then we will see what to do with that. But many times.
No, my point is this: we can go with three classification. One is variation with repetition, permutation, and combination. Then three will be defined.
Sir, that can also be done, but just to simplify and emphasize on one thing, this course is designed in such a way that it will be first take one thing, then second thing, third
No,
thing.
I was making a clarification like permutation is also variation, right? But all variations are not permutations.
Yes.
Permutation is also variation.
Yes, there is one slide also on which I have clearly mentioned that both are similar, but not too similar.
Yeah. Permutation is also variation, but variation is not permutation always.
Yes, always correct.
Oh, thank you.
So if no further doubts are there, today's class is over. I will share the link of the recordings with you. And since tomorrow there is no other meeting by now, I came to know. So tomorrow's 10 to 12 class will be as it is. Okay. See you all tomorrow.
Sir.
Yeah.
Sir, when we have
Anjana.
to submit our assignment?
15th, tomorrow.
Tomorrow, no? Okay.
So there is one building after canteen annex. Earlier it was known as Shed 2, and the one board is there now, Environmental Management Services. There you have to come and submit to me.
Okay, sir.
Okay. Okay then. Have a nice day.
Thank you, sir.
Thank you,
Welcome.
sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Welcome.